In this lesson, we want to talk about the difference quotient. All right, so when we talk about the difference quotient, it's going to be something we need to understand before we kind of get into our calculus course. You're going to pretty much use this right away in calculus when you start talking about derivatives. So what is the difference quotient? Well, essentially, this is just the slope formula that we're used to working with some fancy notation. Okay, that's all it really is if you want to boil it down. So let's say we revisit our slope formula. Let's say that we have a line, and on that line we have 2 points. So one point is P, another point is Q. And the point P has the coordinates x sub 1, y sub 1. The point Q has the coordinates x sub 2, y sub 2. We already know that the slope m, now specifically say lowercase m here, is equal to what? You could say it's the change in y over the change in x, or you could say it's the rise over the run, or you could say it's the difference in y values over the difference in x values. Lots of different ways to kind of remember this. For the slope formula, it's just y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, and then we say x sub 2 minus x sub 1 can't be 0 because, again, division by 0 is not defined. All right, so generically, if we look at this on a graph, we can kind of use this to get into our difference quotient. We'll see this is helpful in a minute. So let's say this is point P, this guy right here, and this is point Q right here. So this is x sub 1, y sub 1. This is x sub 2, y sub 2. So we know, again, the slope m is equal to what? The change in y values over the change in x values. Or you could say y sub 2 minus y sub 1. So the difference in y values over x sub 2 minus x sub 1, the difference in x values. Okay, very, very easy formula to remember. Something you should know at this point. Now, let's say we start using function notation, okay? If we have this guy as, again, point P, and this guy, again, as point Q, instead of saying that this is x sub 1, y sub 1, using function notation, we can say it's x comma f of x. We know f of x is just a fancy way to write y, okay? So don't let that fool you. It's just y, right? It's just x comma y. We're writing x comma f of x. For this guy right here, it might kind of trip you up for a minute. You have this h here and this h here. So what does that mean? Well, if you look at this graph here, the horizontal distance from point P to point Q, we've said this is h, right? It's h units away. So if this is x, then this guy right here, this x coordinate, since it's h units away, is going to be x plus h. Okay, that's all it is. This just took the place of my x sub 2 comma y sub 2. Okay, we just changed it with some fancy notation. And then we say comma f of x plus h. So again, this is just taking the place of y. That's all it is. Nothing that's too fancy. Now, we can take this kind of new notation and we can get our difference quotient. So point P, again, is x comma f of x. Again, this just took the place of x sub 1, y sub 1. And then Q, that point here, x plus h is the x coordinate, and f of x plus h is the y coordinate. So this guy, again, this was x sub 2 comma y sub 2. So if we plug this in this way in our slope formula, m equals what? Again, we used to have y sub 2 minus y sub 1. Well, now we just say f of x plus h minus f of x. So it's just the difference in y values. It's the same thing, just fancy notation. Then down here, we used to say x sub 2 minus x sub 1. Again, it's just the difference in x values. So you have x plus h, this guy right here, minus x, this guy up here. Okay, so that's all it is. And we say h can't be 0 because what happens is this x minus this x leaves me with just an h in the denominator. So really I can say m is equal to, we have f of x plus h minus f of x. Okay, so this is just the difference in y values over your h, right? This is going to be the difference in x values. They're going to be different by h units, right? Because that was the horizontal distance between point P and point Q, okay? And again, we say that h, this guy in the denominator, cannot be 0 because division by 0 is undefined. All right, so when you encounter this in your course, what you're going to end up doing is you're going to be given a function and you're going to be told to find the difference quotient, okay? So all this really is just kind of plugging things in and simplifying. Once you see a few examples, it becomes very, very easy. It's just something that you can make mistakes on because it is a little bit tedious. So suppose we see y equals 5x plus 4, okay? The first thing is, if you don't have it in a format of f of x equals something, go ahead and put it in that format first. So we'll say this is f of x is equal to 5x plus 4. Now, if I find the difference quotient for this guy, what do I expect it to be? Remember, this is in slope-intercept form. I already know that the slope is 5, right? So I would expect that if I find the difference quotient for this function, I would get a result of 5, okay? So let's go ahead and try this out. And let me just write this formula out again. So it's f of x plus h minus f of x, and this is all over h. Now, what I'm going to do is, again, if I see something like f of 3, what does that mean? It means to plug in a 3 everywhere I see an x. If I see f of a, what does that mean? It means to plug in an a everywhere I see an x, okay? So if I see f of x plus h, I just plug in an x plus h everywhere I see an x. So for this guy, f of x equals 5x plus 4. If I had f of x plus h, that would be what? That would be 5 times, where I have an x here, I'm just going to plug in an x plus h. That's all I'm doing, nothing fancy. So x plus h gets plugged in there, and then you have your plus 4, okay? Then the second part of this is to subtract away the original function, which is just this 5x plus 4. Now, be very careful here, because this is where people make these sign mistakes. You've got to subtract the whole thing away. So don't just put minus 5x plus 4. That's going to give you a sign mistake. You want to subtract the whole thing away. So wrap it in some parentheses. That's going to remind you to distribute. So this becomes negative 5x minus 4, okay? All right, so once we have this, we can write it over h, and then we can start simplifying. So let me scroll down. So let's go ahead and say this is what? 5 times x is going to be 5x. Then plus 5 times h is 5h. Then we have plus 4. We have minus 5x. We have minus 4. This whole thing is over h. What you're going to see with these is a lot of stuff's going to cancel. So 5x minus 5x is gone. We have 4 minus 4 is gone. So you end up with 5h over h. And we know that this is going to cancel with this and just give me 5. This is exactly what we expected to get because, again, the line was in slope-intercept form. And we knew that the slope of that line was 5 to begin with. Okay, so we got the expected result. All right, let's look at something a little bit more challenging. It's just more tedious, not necessarily more challenging. So we have 3x squared minus 5x minus y equals 1. Again, if you don't have f of x, if you don't see that, this guy is in implicit form, so it's not even solved for y. So you have an additional step here. What you have to do is solve this for y first, and then replace y with f of x, and then you can go through and find the difference quotient, okay? So I would just add y to both sides, and I would subtract 1 away from each side, and that would give me y. So I would say this is equal to y. We know that this cancels. Over here, I would have my 3x squared minus 5x. We know that canceled, so minus 1. I like the dependent variable to be on the left. So let's go ahead and write it that way. Let's say that y is equal to 3x squared minus 5x minus 1. Now, I'm going to replace y with f of x. So let's just erase that and put f of x. And now we can find the difference quotient. We're going to do the same thing we just did. It's just going to be more tedious. So we're going to say that we want f of x plus h minus f of x all over h, okay? So again, if I have x plus h inside the parentheses, that's what I'm going to plug in here and here. That's all I'm doing. There's no trick to it. So what I'm going to have here is 3 times inside the parentheses, I'm going to put x plus h, and this guy is squared. Again, I just plugged in for x. So I put x plus h there, and then I squared that result. Then I'd have minus 5 times, again, I've got an x, so plug in an x plus h, and then I have minus 1. Okay, so that's the first part. You've still got to do minus f of x. So I've got to subtract away, and I'm going to put parentheses around this. I've got to subtract away this original function f of x. So this is 3x squared minus 5x minus 1. And then once that's done, I want to put the whole thing over h. All right, so let's see what this gives me. There's a lot of stuff to simplify here. So I would have 3 times, if I expand this, remember I can use my special products formula for that. This would be x squared plus 2xh plus h squared. And then over here, I would have negative 5 times x, which is negative 5x. And then negative 5 times h, which is minus 5h. Then I have minus 1. And then I have to distribute this negative to each term. So I'd have minus 3x squared. I'd have plus 5x. and I'd have plus 1, and this is all over h. Okay, so a lot of stuff there. All right, so let's keep going here. All right, so I'm going to distribute this to each term. So I'm going to have 3x squared plus 6xh plus 3h squared. Okay, just distributed the 3 to each term there. Then I'd have minus 5x minus 5h minus 1 minus 3x squared plus 5x plus 1 all over h. Okay, and I know this gets kind of tedious. Okay, so what can we cancel? This will cancel with this. This will cancel with this. This will cancel with this. And that looks like it's about it, right? So we're going to be left with what? Let me put my equals here because I forgot to do it. And let me put my equals here. So I'm going to have 6xh plus 3h squared minus 5h over h. Now, can I make this any simpler? Well, the answer to that is yes. We have an h here. We have an h squared here. We have an h here. We have an h in the denominator. So what I can do is I can factor. So let me kind of copy this. I'm going to bring it to a fresh sheet. And let's just factor this guy. So in the numerator, I'm going to write this as h times the quantity. I'll have 6x plus 3h minus 5. Okay, all I did was I factored out an h from the numerator. This is over my h in the denominator. This is going to cancel and leave me with what? So you'll have your 6x plus 3h minus 5. Okay, so this is going to be your result. All right, let's take a look at an example with a fraction involved. So now we have our f of x equals 3 over x minus 2. Again, if we want to find the difference quotient, for the difference quotient, we have f of x plus h minus f of x, and then this whole thing's over h, okay? So in this first part here, for the f of x plus h, again, where I see an x, I just plug in an x plus h. That's all I'm doing. So I'm going to have 3 over just x plus h, then minus 2. And then you have your minus your f of x. So minus this thing right here. So 3 over x minus 2. What I'm going to do is just write this as plus negative, just to make it a little bit easier to keep track of what's going on. And then I want to write this over h. So I can just write it over h like this. Or if I wanted to, I could do this numerator part first and then write it over h kind of later on. It's up to you. It's the same result either way. All right, so looking at this guy, we have a complex fraction, and we already know how to simplify a complex fraction. We want to find the LCD of all the denominators involved. So what's the LCD of this guy and this guy? Okay, so it would just be the product of the two. So what I would do is I would multiply kind of this top part up here by x plus h minus 2, that quantity, times x minus 2, that quantity. And then this bottom part here by the same thing. So x plus h minus 2, again, that quantity, times x minus 2, that quantity. So again, this over this would give me 1. So I'm not doing anything illegal here. Okay, so what happens is, let me put equals here. This guy, when it gets multiplied by this guy, what's going to happen is that this denominator is going to cancel with this kind of guy right there. So I would just have x minus 2 times 3. So the first part of this is 3 times the quantity x minus 2. And then I have my plus here. Let me kind of undo this now. So now what we're going to do is we're going to multiply this times this. So we're going to see that this is going to cancel with this now. And I'll have my negative 3 times this quantity. So I'm going to put negative 3 times this quantity x plus h minus 2. And then this whole thing is going to be over h times the quantity x plus h minus 2 times the quantity x minus 2. All right, so just working with this now. Let me put equals here. So I'm going to use my distributive property. 3 times x is 3x. Then minus 3 times 2 is 6. And then you're going to have negative 3 times x, which is minus 3x. Then negative 3 times h is minus 3h. And then negative 3 times negative 2 is plus 6. And again, this is all over h times the quantity x plus h minus 2 times the quantity x minus 2. So don't go ahead and multiply that out. Just leave that in its kind of factored form. You don't want to do that because you want to end up with this in the end. Okay. So what you're going to see now is that you can cancel this with this, right? 3x minus 3x, that's gone. You can cancel this with this. Negative 6 plus 6 is gone. So you're just left with this negative 3h here in the numerator. So let's go ahead and write that. So we'll say we have this negative 3h over. You have this h times the quantity x plus h minus 2 times the quantity x minus 2. Okay, so now I can cancel this h with this h, and I'm going to get a final result. So we're going to have negative 3 over. We're going to have the quantity x plus h minus 2 times the quantity x minus 2. Okay, let me make this fraction bar a little bit longer. And so that is my result here. Negative 3 over, you have x plus h minus 2, that quantity, times the quantity x minus 2. All right, let's take a look at this one here. And you're going to see that when you work with kind of this square root operation, you have to do a little bit of extra work. So f of x equals, you have the square root of 7x minus 1. So what I want to do, again, find the difference quotient. So f of x plus h minus f of x, and this is over h. Okay, so I'm going to plug in for x here. Again, if I want f of x plus h, I'm just going to plug in an x plus h. So I would have the square root of 7 times the quantity x plus h, and then I'm subtracting away 1. And then minus, for f of x, I'm going to have the square root of 7x minus 1. And then this whole thing is over h. Now, at this point, you might stop and say, well, really, I can't do much to simplify. I can distribute the 7, right? Let's go ahead and do that real fast. And then I'll show you what else you need to do. So the square root of, you'd have 7 times x, which is 7x, and then plus 7 times h, which is 7h, and then minus 1. And then minus, you have the square root of 7x minus 1. This whole thing is over h. So you might say, okay, well, I can't combine those two radicals there, and I can't really do anything with the h in the denominator, so I'm done. But in fact, what you need to do here is kind of rationalize the numerator, which doesn't make a whole lot of sense, right, at this point. But when you get to calculus, it's going to make more sense for you. Essentially, what you want to do is get rid of the h in the denominator. So that's the expression we're going to be looking for, okay? So what I'm going to do is I'm going to, again, rationalize the numerator. I'm going to end up with radicals in the denominator, but that's okay in this situation. What I would want to do that, remember, if we have a plus b, if I multiply by a minus b, remember, these are conjugates, I end up with a squared minus b squared. Okay, it's exactly what I want to do here. Okay, so what I want to do is I want to take this guy plus this guy. Okay, so I want to multiply top and bottom by that. So let me kind of make this a little cleaner. So this is minus the square root of 7x minus 1. So times, and I don't know if I can fit this all on the screen, but we're going to try. So the square root of 7x plus 7h minus 1. Instead of a minus there, I'm going to use a plus, and then we're going to have the square root of 7x minus 1. So again, same two terms here, square root of 7x plus 7h minus 1 and square root of 7x minus 1. Those two are the same. It's just a difference in sign, okay? So then this is over. I'm going to do the same thing. So square root of 7x plus 7h minus 1, then plus square root of 7x minus 1. Okay, so let me wrap this in parentheses here. And you can wrap this in parentheses. To multiply the numerator, you would use FOIL, right? So essentially what you're doing is the first terms and the last terms only, because the outer and the inner are going to cancel, okay? So the first terms, we know that it's this guy times this guy. So it basically becomes this, the square root of 7x plus 7h minus 1 squared. So this cancels with this, and I'm just left with the radicand. Okay, so that's all I have. Let me kind of slide that down so we have room. And then you're going to have minus, right? Because you have a negative and a positive. So you're going to have alternate signs here. The last times the last. So again, you get in this situation where you have the square root of 7x minus 1 quantity squared. So this cancels with this. I'm left with the radicand, okay? Now, again, you've got to be careful here because you're subtracting away this whole thing. So make sure you wrap it in parentheses, and you'll end up with negative 7x plus 1. So negative 7x plus 1. All right, then in the denominator, we have h times this quantity here. So we have this quantity, square root of 7x plus 7h minus 1, and then plus you have the square root of 7x minus 1. Okay, so what we're going to find is that in the numerator, this cancels. So what I'm left with is 7h over this h times this quantity here. The important thing is that the h here will cancel with the h there, and you're just left with 7 in the numerator. Okay, so let's scroll down and write that. So the numerator is now 7, and this is over. Just this part here, this square root of 7x plus 7h minus 1, and then plus you have the square root of 7x minus 1. Okay, so this is going to be your difference quotient for this guy. again, the reason we did that is so we could get rid of the h in the denominator. When you get to calculus, it's going to make more sense. For right now, just take it as a given. And whenever you have a square root involved in one of these problems, take the extra step to go ahead and do this.